this, though, some of the numbers are given to us in words, okay? If it comes to a stop, that means that the VF is a 0. If it has a constant velocity, that is a clue that the acceleration is 0, okay? Meaning that it's not accelerating, but yes, it's moving. So let's don't forget that. We talked about that. Then we talked about these new equations over here. So what I call these is the Superhero Power Ranger morphed. We are using our traditional 3 equations, or what I call the easy cheesies, and we're combining them to make a new superhero acceleration and 2 superhero displacement equations, okay? Now, again, I did mention that there's a formula chart, and on your formula chart, these equations are there. So I have a formula chart just to make sure. Remember our velocity equations right here, our acceleration, which is the easy cheesy. Look, here's a Superhero Power Ranger acceleration equation and the Superhero Power Ranger displacement equation. But remember, I'm going to scroll down a little bit. Remember this one that I highlighted? Oh, this one I highlighted was telling you, hey, that's the one that we use a lot. That is used a lot. But I turned the page yesterday and I highlighted this one because this one is not on the formula chart. That one's not on the formula chart. And so that's why I highlighted it on the second page. It is a memorized equation. There's about 3 to 4 memorized equations all school year long. That's it. But the great thing about it is that the one above it is on the formula chart. And it's very similar to it. The difference is that I don't have a VI, but I do have a VF. And I'm going to flip the addition to a subtraction. There you go. If you can put that into your head, then there's no worries about it because you have this one in your formula chart to help clue you in. Now let's go ahead and practice again because why did we do this crazy, no calculator, easy, quote unquote, cheesy math quiz yesterday? Well, first thing is, I don't want you to freak out. The math quiz was only 2 points for each question, number 1. So I was like, what? I'm serious, it was only 2 points. I didn't want to kill a grade on you, if that makes sense. But I do need to shake you up a little bit because where I see students go wrong in physics is they forget about the orders of operation or the PEMDAS order of operations. And I understand that that's a topic that's taught like really early in school, but that needs to come back into our mind when we're doing physics. Even though you have a calculator, you've got to be smarter than the calculator and you need to push the buttons in sometimes in a certain way or order so that way you can get the right answer, okay? So let's go ahead and let's do another practice problem over what we call the kinematic equations. It says here that a car accelerates uniformly from rest, VI is 0, and speeds to VF of 23.7 meters per second. Now, it took 6.5 seconds for this amount of velocity to change. Find, question mark, the displacement. All right, so when we're doing kinematic equations from here on out, my suggestion, number 1, is to write your variables. V, I, V, F, D, T, A. Which order, I don't care, but I suggest, because it's going to help organize your thoughts a little bit better and easier to figure out which equation I need. VI right here, since I labeled and identified the variables, it's 0. VF, 23.7. D is my question mark. T, 6.5. But Miss Munson, what about A? They never gave it to me. And this is where, if you have questions, I'm not going to be very helpful if you don't kind of start writing out all your stuff. I want to help you, but I need you to help yourself. And how do I do that? I label everything. I'm going to put an X there because it is missing. It was never given to me or never talked about or discussed. Okay, now I'm going to go to my flow chart. Let me go ahead and scroll down. The first question on my flow chart was distance ever used, talked about, discussed, looked for. Yes, that is my unknown. It's a question mark. Okay, so then in that case, I got to come over here and go to question number 2. Was T ever used, talked about, or discussed? Yes. Look, they gave me a T. The answer is yes. So then you go to the next part, and we can call this question number 3. I guess I should have wrote that in. Let me go back and write this in. Question number 3. Well, that pink pen is no good to me. Let's go for another pen. Question number 3 is, did they give you the VI or the VF? That's it. That's question number 3. And so I actually got both, Miss Munson, but look at the order that I gave you the equations. I gave you this equation on top, and I gave you this equation on bottom. Let's go with the one on top, okay? It's a little easier when I've seen students when they're typing in versus subtraction. Addition just seems to be a little bit easier. Like I said, you can do the bottom one. The cool thing about kinematics is that there's more than one way to come up with the answer. If you prefer to do the bottom one, you go for it. If you want to do the top one, you go for it. I personally have noticed that the top equation is normally the easier equation to use. So I'm going to go ahead and go with the easier equation, VI times T plus 1/2 AT squared. Let's plug in our numbers. Distance, I don't know. VI, 0. T, 6.5 plus, this is where, what did I say like this past few weeks? We do not like fractions. So let's convert that into a decimal point, which is 0.5. Multiply by A. Whoa, Miss Munson, A was never given to you. So I'm just going to put A. T is 6.5. Miss Munson, I thought you said that your flow chart was really good. It really is good. And to be honest, that is the equation I am going to use. No, Miss Munson, you can't solve when you're missing 2 variables in an algebra equation. I agree with you, but listen to this. My flow chart is guiding you here. That doesn't mean that that is the only step that you have to do. When I cannot solve my equation using my flow chart, then that's an indication that this is a 2-step problem. One more time. When I use my flow chart correctly, and look, I cannot solve when I'm missing 2 variables algebraically. I agree with you. But this is an indication that this is a 2-step problem. So what we're going to do is we're going to come over here, and I'm going to write a number 1, and I have to solve for something. I'm going to solve for the acceleration first. A equals VF minus VI over T. Sorry, my mind went blank for a second. VF is 23.7, VI is 0, T is 6.5, 23.7 minus 0 is 0, divided by 6.5 comes out to 3.6. I'm going to round that second digit up. That's normally where I personally stop. Meters per second square. Okay, that is not my answer. That is my A, acceleration. Now, I can come over here and I can say, whoa, I know what you are now, 3.65. I can come over here and I can put in 3.65 and then solve the equation. That's it. My flow chart was still very good. So 3.65, I'm going to multiply that by 6.5. I'm going to multiply, yes.
6.5 squared.
Oh, good call. Thank you. Look at that. Oh. Thank you, thank you. That 6.5 is absolutely squared. Let me go back. So I like equation number 1, and the most reason why is because most of the time my VI starts off at 0, so 0 times anything is 0, so that cancels out. Distance equals 0.5 multiplied by 3.65, multiply when I squared this, I got 42.25, times that by 3.65, times that by 0.5, I end up with a distance of 77.11 meters. Confusion? Maybe. That's okay. We're going to keep going. We're going to practice. We're going to practice. Let's clear that out. Turn the page when you're ready. Now, here's where we stopped on number 2. We set it up, but we did not solve for it. Not a problem. Let's go ahead and do that. 0 squared is just 0. And then if you're going to take away 0, that's just nothing. So I'm just going to X that out. I'm going to go ahead and get 0.5 equals VF squared over, well, I need to get 2 times 4.75. That is 9.5. So that's where I'm at right now, algebraically. Well, I still need to isolate and get VF by itself, but VF is squared. So I'm going to, and then please let me know if something looks off. I'm going to multiply by 9.5 so I can cancel. Multiply by 9.5. I'm going to end up with 4.75 equals VF squared. I cannot have that as my answer. I have to do the opposite of that square. I got to get rid of the square, which is the, I agree, I heard somebody say it. I agree with you, so I'm going to square root it. And so the square root of that, what is that, Soto? This is a different calculator. I just don't know where the button is.
Square root of 19 over 2, which is roughly 2.18.
2.18. VF equals 2.18 meters per second. Does that look right? I don't know. I don't know where the square, where's this square button here? Is that it? There you go. Looks awesome. There goes our answer. I like that question because, again, you just saw on question number 1, my brain completely forgot to put a square at the end. We can't forget that. Also, though, I know that you know by now the opposite of a square is a square root, so please don't forget to square root anything, any variable that has a square. You can't leave it like that. We have to square root it so that way we can find that out. Other than that, let's do one more. Trey, your questions are 3, 4, 5, or 6. Which one do you want? 3, 4, 5, or 6? One more. Anyone? Pick a number for us. He's looking for the easiest. And pick the hardest. Pick the hardest. Give us a challenge. 9 a.m. in the morning. 9:25. Give us a challenge. Which one? Logan's helping you out? Which one do you want? What do you want? I'll do any one of those. 3, 4, 5, or 6. 3? Okay, let's go for it. Let's go for it. Let's do 3. I don't know what 3 says, but let's look at it. Okay, so here we go. It says here that we've got Marissa's car accelerates uniformly at a rate of now it does say positive 2.6. A positive or no positive, which still indicates a positive, means that my object is doing what? Speeding up. How long does it take? Okay, so let's see. Here's my acceleration number. How long does it take, as in question mark time, for Marissa's car to accelerate from VI to VF? All right, step number 1, let's write down our variables. VI, VF, D, T, A. Those are my 5 kinematic variables. VI is 8.85. VF is 9.65. Distance was never given, talked, or discussed. So I'm going to X that out. T, well, that's my unknown. A, 2.60. Alrighty, using that flow chart, because we're going to use that flow chart for this whole semester. The first question, only because I have it memorized, was D ever used, talked about, discussed, looked for, given, or anything? No, we X'd it out. So my flow chart says, stop. Let's use the easy, cheesy acceleration equation. Alrighty? A equals VF minus VI over T. Let's go ahead and fill in the blanks, and let's see if this will work. 2.60 equals 9.65 minus 8.85 over T. There you go. Heck yeah. Perfectly good. Let me go ahead and get 9.65, take away 8.85. I'm going to end up with 2.60 equals 0.8 over T. That's unacceptable. We need to isolate T by itself. So I'm going to multiply by T, cancel, multiply by T. Oh, snap. T is still not by itself. Divide by 2.60. Divide by 2.60. T, you might want to double check my math, but I just did it right here. I got 0.3, and I'm just going to round up 1 second. I like that. Man, this is a pretty good flow chart. And like I said, when we see something that just doesn't look right, that's probably an indication that that is a 2-step math problem. Alrighty. Other than that,